So line is one-dimensional and plane is two-dimensional. So if you need to write the equation of a two-dimensional surface on or in a space, in a three-dimensional space, then there are three requirements that are there. Okay, so you'll be able to write it provided you know the normal to the plane and its distance from the origin. That is, you have a plane, you know the perpendicular distance to that plane from the origin, and you also know the normal to it, then you can write it. Second, you can also write the equation of a plane if you know the points through which it is passing. So if you know the point through which it is passing and the perpendicular of a given direction. Third, if you know the three non-collinear points through which it is passing. Okay, so these are the three data which you need to write the equation of a plane. So if the first one is getting satisfied, then we call it as normal form. Second one is getting satisfied, there is some other name. Third one, then we call it as equation of plane through three non-collinear points. Let's see one by one. So what is the first thing? First is equation of a plane in normal form. So write it down. I want everybody to write it along with me. This is slightly a tricky exercise. If there is any doubt, get it clarified. Equation of a plane in normal form. Okay. So what are the required data? See. So what is that you need to know? You need to know the normal to the plane, and you need to know the distance from the origin. So these are the two required data. Okay. So for that, we will consider this diagram. I'll show it how you are supposed to visualize it. Okay. So listen. So here, so O is origin, obviously. So O has the coordinate 0, 0, 0. Okay. D is the perpendicular distance from origin to plane, and ON is normal to the plane. Okay. See, I'll show it to you. Just give me a minute. So I hope you're able to see me, right? So let's say this book is a plane. You need to write the equation of this plane. Okay. So when you need to write the equation of this plane, what are all the required data is? You need to know the normal vector to this. Okay, normal means to this plane something which is perpendicular. You need to know something like this. Okay. Similarly, what you have is so let us assume x-axis, y-axis, and z-axis is towards me. There is a plane like this. Okay. So what you know is to this plane from the origin, you know the perpendicular. That is, it is like this. So pink color pen is the normal. You know something like this. Okay. So remember, this is O. The foot of the perpendicular on the plane is N. Okay. And the distance from the origin to the tip of this, that is till the end of this plane, is D. Are you guys able to visualize?
Yes, sir.
Right. So for you to write the general equation, what are we supposed to do? I told you in straight lines also, for you to write down the general equation. So you know the foot of the perpendicular n. You can take some other point on this plane named as p x comma y comma z. Right? So if I take a point P here from the origin, what will happen is this. Okay. So from the origin, let's say this point is R and this is the normal. Okay. So point P is this point and N is this point. So P and N both are on the plane of this, on the plane for which you are planning to write the equation for. Right. So keeping all these things in mind, let's try to write down the equation. See. So ON be the normal to the plane. Let P x comma y comma z be a locus point on plane. Right. So what is OP vector, guys? OP vector will be xi cap plus yj cap plus zk cap. Right. What is ON vector? See, if you observe, for the foot of the perpendicular, we don't have coordinates. Rather, we have another information. We know the length of it. What is the length of ON?
D.
So D, and the unit vector in ON be n cap. Okay, where D is distance or length of perpendicular, and n cap is what? Is unit vector of normal. I hope it is clear, guys. Right. So since P and N are points on the plane, can we write Pn vector as On vector minus OP vector? So what is ON vector, guys? It is dn cap minus, or I'll do one thing. I'll take it as NP. If you, so you can write it in any of the ways. I'm just going with the book definition. So if I write it as NP vector, it is going to be OP vector minus ON vector. What is OP vector? R vector minus ON vector is dn cap. Right? So R vector minus d into n cap is a vector in the plane, and ON vector is perpendicular to plane. Accepted? So can I say that NP vector and ON vector are also perpendicular to each other? Hence, NP vector is also perpendicular to ON vector. Accepted, guys? Which implies, so what is the condition for perpendicularity between two vectors? R vector minus dn cap dot dn cap should be equal to 0. Since NP vector dot ON vector is equal to 0 because they are perpendicular. So what will you have? R vector dot dn vector or dn cap minus d square into n cap dot n cap is 1. That is equal to 0. So R vector minus R vector dot n cap, I take the d outside because it's a scalar, is equal to d square. So d and d will get cancelled, which implies R vector dot n cap is equal to d. This is the normal form of a plane. Okay. So this is the general equation for a plane. In which form? In its normal form. Write it down. And moreover, it is a vector form, right? So I'll finish Cartesian form also, then you can write it down. So what will be the Cartesian form? R vector is xi cap plus yj cap plus nk cap. N cap will be li cap plus mj cap plus nk cap. Okay, here LMN stands for unit direction cosines. I already told you the coefficients of ijk in any vector will be direction cosines if it is a unit vector, whereas they will be direction ratios if it is any other vector. So xyn can be called as the direction cosines of, direction ratios of R. Lmn will be the direction cosines of n. Right? So when you do the dot product between them, you will get Lx plus My plus Nz is equal to D. This is the Cartesian form of equation of a plane in normal form. Okay.
So could you scroll up a little bit?
Yeah. So first listen, then I'll give you time to write.
Okay.
Yeah. If so, remember L comma M comma N are direction ratios of normal. They are not the direction ratios of the plane. They are direction ratios. Direction cosines. That's direction cosines of normal. They are not of the plane. If A comma B comma C are dRs of normal to the plane, then AX plus BY plus CZ will be equal to capital D, where this capital D is not the distance. Small d is the distance, capital D is not the distance, capital D is some constant. I will explain everything when we solve a problem. I'll tell you how this data will be useful when you solve a problem. Okay. So please make a note of all these points. Is this okay? Can I show it from here or you want me to show it from some other point?
Yes, sir,
Is this fine?
Yes, sir.
Okay. Guys, write it down.
Towards small.
Sorry.
So could you repeat what small d is?
Small d is the distance from the origin to the plane. That is the perpendicular distance. Small d is perpendicular distance.
What about capital D? Sir?
It is some constant. It is some random constant. I'll tell you why it is so. First copy this, I'll tell you. Done? Okay. I'll do a problem and show, then I'll explain why that has come. See, concentrate. I'll tell you what are all the common mistakes that happen. Find the vector equation of a plane which is at a distance of 6 by root 29 from the origin. So what is given here? Small d is given. 6 divided by root 29. And its normal vector from the origin is 2i cap minus 3j cap plus 4k cap. So what is that? What is the equation of a plane in the normal form? R vector dot n cap is equal to d, where R vector is a general point, right? It is a general point. So what else is given now? So d is given. What else do we need? We need n cap. So n cap is given, right? It is 2i cap minus 3j cap plus 4k cap. Am I right? So you're able to understand. So they're asking the vector equation and they're asking the Cartesian form also. Did you understand how I took the data?
Yes, sir.
Okay. What I took is actually wrong. Because, can someone tell me why I'm wrong?
Sir, n cap is a direction, sir. How can we take a vector?
N cap direction only. It is direction means what did I say? The
Sir,
coefficients are up. The coefficient should be what?
unity.
The coefficient should be direction cosines. Okay. So here it is not n cap. Look at the correction I'm making, guys. This is the common mistake that happens. That is why I was stressing. It is n vector that is given. But for what is the general equation of plane telling? R vector, the dot product should be done between R vector and n cap, not between n vector. So the one which is not given in the textbook is, the other way of writing is R vector dot. How can you write n cap in terms of its vector? Can I write it as n vector divided by the magnitude of n vector is equal to d? Accepted?
Yes, sir.
So please make a clear note of this, okay? You should not do this mistake. R vector dot n cap is equal to d is one equation, or R vector dot n vector is equal to d into n, where n is the magnitude of the normal vector. This is another form of writing. So n vector is given. So what is n cap, guys? N cap will be 2i cap minus 3j cap plus 4k cap, the whole divided by square root of 4 plus 9 plus 16. How much is this? That is 2i cap minus 3j cap plus 4k cap, the whole divided by root 29. This is n cap. Now can I directly write the equation? So hence the required vector equation will be what? R vector dot n cap is equal to d. Because I have already acquired n cap, I will write it like this. So R vector dot, what is n cap, guys? 2i cap minus 3j cap plus 4k cap, the whole divided by root of 29 is equal to 6 divided by root 29. Root 29 and root 29 will get cancelled. So from this I will get R vector dot 2i cap minus 3j cap plus 4k cap is equal to 6. This is what form? This is the vector form. Okay. Now for the Cartesian form, what are we supposed to do? For the Cartesian form, you will take R vector is equal to xi cap plus yj cap plus zk cap. So when you do the dot product, you will get 2x minus 3y plus 4z is equal to d. Now observe, guys. I'll give you two options. Tell me which is right. Lx plus my plus nz is equal to small d, or ax plus by plus cz is equal to capital D. So the Cartesian form that I've written, does it belong to the direction cosines form or direction ratios form?
Direction ratio.
It belongs to the second one, yes. Okay. So that is why I told when you're writing the right side constant, it is not small d, because what is small d? The distance is 6 by root 29. This 6 represents some other constant.
Sir, can you explain the last point, sir?
Which one? See, Lx plus my plus nz, if you're writing in such a way that the coefficients of x, y, z are direction cosines, okay, then right hand side represents the distance from the origin to the plane. Whereas if you're writing in the form ax plus by plus cz is equal to capital D, where a, b, c represent the direction ratios, then capital D does not tell you the distance from the origin to the plane, rather it is some other constant. Okay. See, for example, if I had to write the same thing in the form Lx plus my plus nz, then the equation would have been 2x minus 3y plus 4z the whole divided by root 29 is equal to 6 by root 29. Why did I write root 29? Because it is square root of 2 square plus 3 square plus 4 square. Okay. So here, whatever I've written, this is in the form Lx plus my plus nz is equal to 0. Because 2 by root 29 will be L, minus 3 by root 29 will be m, 4 by root 29 will be n, and 6 divided by root 29 will be the distance from the origin to the plane. Guys, are you clear?
Yes, sir.
Yes, sir.
Yeah. So see, I've seen many of them doing this mistake. If you don't have this clarity, there are some problems where you need to calculate foot of perpendicular and all. You will not understand. So ensure you're thorough with this. Okay. Shall I move on to the next one?
1 minute.
Yeah.
Done, sir.
Okay. So look at the next question. It is slightly twisted. Find the direction cosine. So they are asking direction cosines. Have it in your mind. Lmn of whom? Of the unit vector perpendicular to the plane, which is given like this. So in the previous question, what they did is they gave you the normal vector and distance, and they ask you to write the equation. Here, what have they done? They have given you the equation. They are asking what are the coefficients of unit normal vector. So given equation of plane is what? R vector dot 6i cap minus 3j cap minus 2k cap. Can I write it as minus 1? Okay. It is in which form? R vector dot, I'll give you two options. Tell me which is right. N vector is equal to D, or R vector dot N cap is equal to D. Which is right?
N cap.
It is actually N vector. Because, see, remember, whenever it is N cap, right? What did I say N cap is? N cap is unit vector. So the coefficients will be direction cosines. Look at the coefficients. If a vector is given like this, I'll write, if the vector is given like this, pi cap plus qj cap plus rk cap, if the value of p, q and r are less than 1, so first condition that you need to check for is, if you have to write this for a unit vector, if it is for a unit vector, then p, q and r should be less than 1, and p square plus q square plus r square should be equal to 1, because what is the relation between all the direction cosines? L square plus m square plus n square is 1. So if this condition is not getting satisfied, then what are the coefficients? The coefficients are direction ratios. So here now rethink. So 6, 3 and 2, they are definitely not less than 1. Right. So what do they represent? So this vector represents n vector or n cap?
N vector.
It is
N
n
vector.
vector. I hope you're clear, guys. So this is wrong. Okay. Secondly, can I compare these two? So one thing we are clear now is we understood that the vector which is given is in the form r vector dot n vector is equal to d. So can I start comparing these two equations? Yes or no? Say, I want a response, guys.
Yes, sir.
Can I?
Yes, sir.
Okay. So if I compare, one mistake that will come. Can someone tell me what is the mistake that will happen when I directly start comparing both?
Small d is not 1, -1.
Why?
Because it's a constant, so it's in the form of direction ratios.
Uh-huh.
It's a
What you
distance.
told is right. Exactly. It's a distance. What you told is right, but your reason is wrong, right? So, yeah. So D represents what? It is a distance. Distance can't be negative. So before you start comparing both, the first thing that you're supposed to do is convert it into a positive form. So if this has to be positive, multiply left hand side with negative. So minus 6i cap plus 3j cap plus 2k cap is equal to 1. Now you can compare it with r vector dot n vector is equal to d. Okay. Now what are they asking? Now read the question again. Find the direction cosines of the unit vector perpendicular to the plane. So this is the vector which is perpendicular to the plane. So comparing these two equations, we get n vector is equal to minus 6i cap plus 3j cap plus 2k cap. Then what is n cap? Minus 6i cap plus 3j cap plus 2k cap, the whole divided by square root of 36 plus 9 plus 4. How much is this? Root 49, that is 7.
7.
So minus 6 by 7 I cap plus 3 by 7 j cap plus 2 by 7 k cap. So what are the required direction cosines? Minus 6 by 7, 3 by 7 and 2 by 7. Don't put it within a bracket. If you put it within a bracket, it is understood like a point. Guys, am I clear with this?
Yes, sir.
Yes, sir.
Okay. So please make a note of all the important points I'm stressing upon. This is considered to be one of the toughest exercises. Many people struggle. So if there is any doubt, please ask and get it clarified.
Sir,
Yeah, tell me.
sir, instead of n vector, if we take n cap, will our answer totally change?
Yes, it will, because mathematically it is wrong, no? If I write n cap is equal to, if see, means you're directly trying to compare this equation and this equation, right? So even
Yes, sir.
if at all you want to take it as n cap, okay, let's assume that we are doing that mistake. Let's say you're doing n cap also. Again, you need to ensure the right hand side is positive because it's distance. So when you make right hand side positive, you'll get n cap is equal to minus 6i cap minus 3j cap minus 2k cap. Am I right? So find out what is the magnitude of this and tell me. So you are writing it as a unit vector, but if I find the magnitude of it, I get root of 36 plus 9 plus 4. It is definitely not equal to 1. But you are calling it as a unit vector. Is it possible? Kritika, you are able to
Okay,
understand
sir.
the mistake?
Oh, got it, sir. Got it, sir. Got it,
Yeah,
sir. Yes.
yeah, that's the reason. Shall I move on, guys? Now see. Look at the 15th question. So the 15th question, they have given 2x minus 3y plus 4z is equal to d. So solution. 2x minus 3y plus 4z is equal to 6. Now I'm giving you two options. Lx plus my plus nz is equal to d, or ax plus by plus cz is equal to capital D. Which is right?
Second.
Second. Reason? The coefficients of x, y, and z are not less than 1. So there itself it is rejected. Right? 2, minus 3, and 4 are not less than 1. So how will you convert it to normal form? So what will be the vector form, guys? Can you write it in the reverse? What will be the vector form? R vector dot, look at the way I'm going to write. 2, in the place of x, I'm replacing it with I cap minus 3j cap plus 4k cap is equal to 6. Am I right? So r vector dot 2i cap minus 3j cap plus 4k cap is equal to 6. Right? So it is of the form r vector dot n vector is equal to capital D. Is equal to capital D. Right? So how to find the distance? You guys tell me. So when it is of the form r vector dot n vector is equal to capital D, to find the distance, okay, let's make it simple. So since it is r vector dot n vector is equal to D, you guys tell me what are we supposed to do? So if I have to write it as r vector dot n cap, what am I supposed to do to this vector? 2i cap minus 3j cap plus 4k cap, the whole divided by square root of how much?
25.
4 plus 9 plus 25, 29, no?
Yes, sir, 29.
So 6 divided by root 29. So what I'm trying to do is, so the method is whenever you have in the form r vector dot n vector is equal to capital D, divide both sides with square root of a square plus b square plus c square, where a, b, c are what? Direction ratios of normal. When you do this, now it has got converted to which form? So this I can confidently say it is of the form r vector dot n cap is equal to D. Now what is the distance, guys? 6 by root 29 units. So let's go. Okay. Next. This is the one. I told you, right? There will be a problem based on foot of the perpendicular. Find the coordinates of the foot of the perpendicular drawn from origin to the plane. 2x minus 3y plus 4z is equal to 6. Okay. So try to visualize it. I'll take a plane like this. So I'm taking a plane like this. So what is the equation of this plane, guys? It is 2x minus 3y plus 4z is equal to 6. What do these 2, 3 and 6, 2 minus 3 and 4 represent? 2 minus 3 and 4 are
Direction ratios.
Direction
of
ratio.
whom? Of whom? Direction ratios is right. Direction ratios of whom? Of, listen to this carefully, normal to the plane. Many of them think that it is a direction ratio of the plane. No, it is direction ratio of the normal to the plane because all these coefficients are coming from n vector. Okay, n vector itself is a vector which is normal to the plane. So what are they saying? From the origin, there is a perpendicular dropped. If this point is P, our interest is to find what is the foot of the perpendicular. Let's call this foot of the perpendicular as alpha, beta, and gamma. Am I clear, guys?
Yes, sir.
Right. So now listen. Since 2 minus 3 and 4 are what? direction ratios of normal to the plane from where? From origin. Accepted. And OP is also normal to the plane because it is the perpendicular, right? So what will be the direction ratios of OP, guys? So what is the direction ratio of a line joining 2 points? X1, X2, X1 by 1, Z1, X2 by 2, Z2. What is the direction ratio?
x2 minus
X2
x1.
minus x1.
Yes, that's right.
minus one.
X2 minus, so alpha minus 0, beta minus 0, and gamma minus 0. Right? Since, 1 minute. This way. Okay. Since ON and OP are parallel to each other, okay, since ON and OP are parallel to each other, can I say their direction ratios will be in same proportion? Because we don't know what is where is n. Okay, n is definitely not the foot of the perpendicular. Okay, so listen. So ON and OP are parallel to each other. Direction ratios will be in same proportion. So can I say alpha divided by 2 is equal to beta divided by minus 3 is equal to gamma divided by 4 is equal to k. I'll call it as some constant. So which implies alpha is equal to 2k, beta is equal to minus 3k, gamma is equal to 4k. Accepted? Then the points of the foot of the perpendicular will be 2k comma minus 3k comma 4k. Since this point lies on the plane, can I take this point and substitute it in the plane? Okay. So 2k minus 3k comma 4k satisfies what? Equation of plane. Right. So when I substitute it, what will I get? So 2 into x is how much? 2k minus 3 into minus 3k plus 4 into 4k is equal to 6. So 4k plus 9k plus 16k is equal to 6. So k will be 6 by root 29. So what will be the required equation, required point? So required point will be, what will be the required point? 2k, that is 12 by root 29, comma, minus 3k. So minus 3k is how much? Minus 18 by root 29, and 4k, that is 24 divided by root 29. This point is the foot of the perpendicular from the origin to the plane. Okay. So I'll give you a block diagram, a flow which you're supposed to follow. Steps to be followed to find foot of perpendicular or image of a point with respect to a plane. First step.
Sir,
Ah,
in the previous step we have written 4k plus 9k plus 16k is equal to 6, and in the next step you've written k is equal to 6 by root 29.
oh,
How
it
is
is
it, sir?
only, no, it is only 29. I'm sorry. Only 29. Now I got used to that problem. I think that is the answer, right? 12 by 29. Yeah, 12 by 29. I had this in mind. Thank you. So this is the required pointers. So first I'll give you the steps, then you can copy it. So there are two kinds of problems that will be asked. Steps to be followed to find the foot of perpendicular or image of a point with respect to a plane. So what you need to do is let given plane be ax plus by plus cz is equal to capital D. Okay, let's say this is the plane that is given. So whenever there is an equation of plane that is given, indirectly what else is given? Write the direction ratios of whom? Of
Normal to the
normal.
plane.
Yes. So this is the first step. By default, you can take the coefficients and write it down. So what will be the second step, guys? Assume the foot of the perpendicular. Let the foot of perpendicular be. So for image also, you need to do the same thing only. For image also, you need to solve using foot of the perpendicular only. So image problem, we'll see it later. As of now, have foot of perpendicular. So let the foot of perpendicular be alpha, beta, and gamma. Okay. So you have the DRs of normal. Find direction ratios of normal joining given point and alpha, comma, beta, comma, gamma. Then what are we supposed to do, guys? You tell me. Given point P, x1, y1, z1. Using what formula? Alpha minus x1, beta minus y1, and gamma minus z1. I hope it is clear till this step. 4. Since normal and the perpendicular line will be parallel to each other, what can we say? Their direction ratios will be in same proportion. Right? They'll be in the same proportion. After that, what are we supposed to do? Find alpha, beta, and gamma in terms of x1, y1, z1, and ABC. Write the direction ratios of the normal of the plane, that is ABC. Substitute alpha, beta, gamma in the equation of plane. Substitute alpha, beta, gamma in equation of plane. And what are we supposed to do? And find K. Okay. That is, it will be like this. Alpha minus x1 divided by A is equal to beta minus y1 divided by B is equal to gamma minus z1 divided by C is equal to K. And K. So substitute alpha, beta, gamma in the equation of the plane and find K. Substitute K in step 4 and obtain alpha, beta, gamma values. Please make a note of this. There is any doubt? So let me know if you're done. Done?
1 minute, sir.
Yeah, right.
Done, sir.
Okay. So problem seems to be big, but it is not. So if you follow these 7 steps, you'll get the answer. Okay. So till now we have seen everything related to normal form. Now we'll go to the next form. What is the next form? Equation of a plane perpendicular to a given vector and passing through a given point. So that we need to write the equation of a plane which is perpendicular to a given vector and passing through a point. Okay. So what is that we are going to consider? See, it's simple. So there's the diagram. Tell me, how shall we proceed? How do we need to proceed? So observe, you have a plane, right? So the plane is here. This plane is passing through a given point P. Actually, here they have taken it wrong. Okay. So I will explain it. Listen. So there is a plane. This plane is passing through a point x1, y1, and z1. Always given points will have suffixes like this. Okay. And what else is known? What else is known? So they've told the plane is passing through a point. What is the other information that we know? The plane is also perpendicular to a given vector. So there is a vector like this to which it is perpendicular to. Right? So this perpendicular vector which is given, let's call it as n vector. Am I clear, guys? Okay. Now tell me one thing. To find the equation of this plane, you need to consider a point. So what will be the general point that you will be considering? X, y, and z. Now tell me one thing. What is OA vector? OA vector will be x1 I cap plus y1 j cap plus z1 k cap. Accepted? OP vector will be xi cap plus yj cap plus zk cap. Let's call this as R vector and let's call this as A vector. So it's like same. Okay. Given n vector. Okay. So you guys tell me, what is AP vector? So
X
AP
minus
vector is,
x1 I cap.
-x1 I cap.
minus OA.
let's first write in the vector form, then we'll go to the Cartesian form. So it is OP vector minus OA vector, final position vector minus initial. So what is OP vector? R vector minus OA vector is A vector, right? And N vector is there. See, AP vector is in the plane, n vector is perpendicular to the plane, so what can we conclude? AP vector dot n vector is how much?
0.
Yes. So what is AP vector? R vector minus A vector dot n vector is equal to 0. This will be the required equation in vector form. Am I clear, guys? So n vector, I'm writing like this: Li cap plus Mj cap plus Nk cap, or Ai cap plus Bj cap plus Ck cap. Out of these two forms, which one is right? If you look at the symbol on top of n, you can tell the answer.
Second one.
It is the second one. So when they say you know the plane, you know the line to which the vector is perpendicular to, sorry, you know the vector to which the plane is perpendicular to, then the vector's direction ratios are given, not the direction cosines. Okay, so what will be the Cartesian form, guys? So you guys tell me. Cartesian form will be r vector is xi cap plus yj cap plus zk cap. So x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap dot, what is n vector? It is ai cap plus bj cap plus ck cap. I think in your textbook they've used capital ABC. It's only a notation. Okay, this should be equal to 0. Then what will be the required equation? A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the required Cartesian equation, and this is the required vector equation. Clear?
Yes, sir. So can you scroll up?
Yeah. This is fine, or you want me to go up?
No, sir, this is fine.
Okay. Done? Listen. Now look at the 17th one. Find the vector and Cartesian equation of the plane which passes through the point phi 2 minus 4. So what is given? x1, y1, z1 is equal to phi 2 and minus 4, and it is perpendicular to the line with direction ratios. So can I directly write n vector is equal to 2 I cap, sorry, on, I'll write it as n vector. N vector is equal to 2 I cap plus 3j cap minus k cap. So from this, what will A vector be? Five I cap plus 2j cap minus 4k cap. Now tell me, what is the vector form, guys? r vector minus a vector dot n vector is equal to 0. I hope there is no confusion between this one and the first one. Right. So r vector minus a vector is 5i cap plus 2j cap minus 4k cap dot 2i cap plus 3j cap minus k cap is equal to 0. Okay. So if you want, you can further simplify it. R vector dot 2i cap plus 3j cap minus 4k cap minus the dot product between these two. That is 10 plus 6 plus 4 is equal to 0. So R vector dot 2i cap plus 3j cap minus k cap is equal to 20. Okay. Now, can you guys tell me what is the Cartesian form? You can directly tell me from the above step. From here, you know how to write the Cartesian form. 2x plus 3y minus z is equal to 20. You need not sit and write that whole process. A into x minus x1 plus b into y minus y1, because both are going to generate the same answer. If you observe, this has got converted to what form? R vector dot n vector is equal to capital D form. So that is the general equation of a plane. Am I clear? Okay. Moving on to the next question. So the next one is, so that's all with the second form. The third form is you need to find the vector equation of a plane that is passing through three non-collinear points. So listen. There is a reason why we are saying three non-collinear points. So listen. So let's say you want the equation of this plane, and there are points A, B, and C, whose position vectors are A vector, B vector, and C vector. Okay. Now, let three non-collinear points be A vector, B vector, and C vector. I'll write it like this. A vector, B vector, C vector. Then what is AB vector, guys? It is B vector minus A vector. What is AC vector? It is C vector minus A vector. What is BC vector? It is C vector minus B vector. Tell me one thing. AB vector, AC vector, and BC vector, all the three are going to lie in the same plane, right? Now comes an important question. If I do the cross product between any two vectors, then how will the resultant of that be? If I do the cross product of any two vectors, AB vector and AC vector, or AB vector and BC vector, then how will the resultant be? Cross product of any two vectors will have its resultant in which direction, guys? in perpendicular direction to whom? To both the vectors for which cross product is performed. Okay. Now see, can I say, so from this can I conclude that AB vector cross AC vector is perpendicular to the plane? Yes. Yes or no? Guys, are you able to understand?
Yes, sir.
Yes, sir.
Okay. Now listen. So I'm taking a general point P, which is R vector. So what is AP vector? AP vector will be R vector minus A vector. So R vector minus A vector is in the plane, and AB vector cross AC vector is perpendicular to the plane. Hence, can I conclude that R vector minus A vector's dot product and AB vector cross AC vector's cross product is equal to 0? So R vector minus A vector dot AB vector cross AC vector is nothing but B vector minus A vector cross C vector minus A vector. This is equal to 0. This is the required equation of a plane which is passing through what? 3 non-collinear points ABC. And the reason why they are supposed to be non-collinear is because had they been collinear, then the cross product between them would have been 0. You will not be able to write. Please make a note of this. Are you done writing?
1 minute.
Minute, sir.
Okay. So let me know once you're done. So listen. Find the vector equations of a plane passing through the points R vector, S vector, and T vector. Instead of ABC, it is given RST. So what is the solution? They're asking what equation? Vector equation. So what is the vector equation? R vector minus A vector dot B vector minus A vector cross C vector minus A vector is equal to 0. Okay. So you need not memorize this actually. It is like this minus A dot, you have a minus A cross something minus A. So start with R, this will be B, this will be C. Okay. So first find what is B vector minus A vector and find what is C vector minus A vector and find the cross product between them and tell me first. Done? What is B vector minus A vector cross C vector minus A? What is the answer, guys? B vector minus A vector cross C vector minus A vector. What is that?
Minus 16 I cap
Minus 16 I cap
plus 24 J cap
plus 24 J cap
plus 32 K cap.
is 32 K. So 16, 8 is common, right? Okay. Now what is R vector minus A vector? So R vector minus 2I cap plus 5J cap minus 3K cap dot minus 16I cap plus 24J cap plus 32K cap is equal to 0. So what do you get? R vector dot minus 16I cap plus 24J cap plus 32K cap is equal to minus 32I cap plus 120J cap minus 69K cap. 96, sorry. I think both the sides is divisible by 8. So R cap dot minus 2I cap plus 3J cap plus 4K cap is equal to minus 4I cap plus 15J cap minus 96 means 16. Huh? How much is it? 96.
Well, so
12K cap. So that's it, right? There is a required answer. Wait. I'm sorry. Minus 32 plus 120 minus 96. So how much is it? That will be minus 4 plus 15 minus 12. So it's minus 1. So the required equation will be r vector dot 2I cap minus 3j cap minus 4k cap is equal to 1. So what is the answer? This problem number what? 17, huh?
18, sir.
18. Oh, they left it like this. Okay. So this is the required equation. So if they ask you for 1 mark, you can actually leave it like this, in this form itself. Okay. So in the next class, we will be discussing the intercept form and how to write the equation of plane. The remaining parts we will discuss. Next class, we will complete this chapter. So before next class, you have to work from problem number 1 to 6. And I've seen there are many of you who have not submitted the previous assignment also. It is very clear that you have not worked on 11.2 also. If you're not working and completing these two by Thursday, please don't attend the class. Do not attend. You're not going to understand anything. It is of no use. Okay. So today's homework is first to sixth problem 11.3. If you have the previous exercise also pending, ensure you complete it. For this chapter, I'll be very particular because this is very, very tough. You guys have to be in the track. Just wait, don't leave.